Okay, so in the review session, I wanted to first talk about the logistics of the exam, which will look a lot like the logistics for exam 1 and exam 2. And then I will talk about time slots, and then I'll go into the content for the exam. So as all of you should know by now, the date of the final exam is August 20th, Thursday. Now for the exam time, as we had for exam 1 and 2, we have time slot 1, that is during the regular class time, 10:30 to 12:30 p.m. Eastern, and then we also will have a time slot 2 the same day, Thursday, but from 9 to 11 p.m. Eastern. Now, if you have signed up for a particular time slot in which you gave your exam to, that's what I'm going to use by default. So I'm going to assume that every student is good with that exam 2 time slot. But if you are not for some reason and you would like to change this, a couple of you have already sent me an email, but you still have time to change your time slot before 11:59 p.m. Eastern tonight. So if you would like to do this, email me right away. But if not, then I'm going to assume that you are good with your exam 2 time slot. And the way you check that is if you log on to Gradescope and take a look at the submission that you made for exam 2, it'll either be midterm exam 2, which was for time slot 1, and then the other one was exam 2 time slot 2. That was obviously for time slot 2. So you can go ahead and check where you submitted your work, where you got it graded, and that's how you can quickly refer to which time slot you would be getting. Now I'm going to be talking more about when I'll send those links to you in just a minute. Now, final exam is going to be made available using the file transfer option in your WebEx meeting. I will do that a couple of minutes before the start of exam time, so that for those of you who have a printer handy can print the exam just the same way we did for exam 1 and 2. Now you guys will be using your own paper supplies, so have a bunch of blank sheets with you and writing supplies handy while taking the exam. And like I mentioned, links to the WebEx meeting for your time slot will be emailed tomorrow before 6 p.m. Eastern time. Now, what do we do with the Gradescope? So similar to what we have done before, the last 20 minutes of exam time, I recommend that you use that for scanning and uploading to Gradescope. And that particular time for time slot 1 is between 12:10 p.m. and 12:30 p.m. Eastern. And for time slot 2, it happens to be the last 20 minutes, 10:40 p.m. to 11 p.m. Eastern time. And make sure that you upload all pages. After you submit, go back and check if your submission went through okay or not. And by now, the fact that you guys have been submitting all your work through Gradescope, at least most of your work through Gradescope, and for most of your classes, I hope you are now very familiar with how to do this process, and you have gotten a lot quicker with scanning and uploading things to Gradescope. Okay, any questions as far as logistics is concerned? So exam times and Gradescope uploading times. Okay, so it seems like most of you, if not all, are comfortable with this discussion so far. Let me move on to the next slide. So what is allowed during the exam? Again, similar to what we have been dealing with throughout the semester. Hard copy books and notes are allowed during exam. So open book, open notes. However, it has to be a physical copy of the book or notes. You will need the Fourier transform properties and tables, Fourier series tables that are uploaded on Piazza. I also provide that at the end of the exam, just as I did for exam 2. But for the final exam, you will also need the Laplace and Z transform tables from Piazza. This can be found under resources, and if you look into general resources, that's where these tables are attached. Um, and I hope you have been using this extensively to do the homework problems. And like I said, this will also be available at the end of the exam, final exam. You will obviously need writing supplies to write your exam. Your laptop or desktop can only be used to view the exam questions. And you can use your computer to type in private questions directly to me for clarification. And you will also use your laptop or desktop for proctoring purposes. Um, what is not allowed during the exam? Well, calculator, an iPad, tablet, your phone, your headphones, earphones, any other electronic devices not allowed during the exam. Questions about what is allowed and what is not allowed? So I'm just going to highlight some things that you are absolutely definitely going to need, so that the first thing that you should make sure is have these things ready. And then depending on the amount of time you have and the other exams that you're preparing for, you can work on making your own crib sheets if you want to, organizing your notes and so on. Okay, let's move. I want to point out this a little bit. I want to stress on this a little bit more. The fact that I don't want to. I don't want any student to be using any headphone or earphone during the exam. That's a strict no-no. So far, I've been looking at the student and have been asking them to put the devices away, and you guys have been cooperating with that. But for the final exam, I'm going to be a little bit more strict. So I hope that everybody is going to follow the rules now that we are familiar with it from exam 1 and 2. Okay. Proctoring, just the same way as exam 1 and 2. You will be required to join the WebEx meeting, to which you will get the link tomorrow. You will be required to join the meeting a few minutes before the start of exam time. I recommend you join before 15 minutes before the start, so that you can get set up. You can resolve any last minute issues that you may encounter. Get settled down 15 minutes before. Links will be emailed tomorrow for the time slot you sign up for. And during the exam, keep your camera on, keep your microphone turned on. You can choose to apply like a fake background or blur out the background if you wish to. That's up to you. That's an option that you have. But your camera and microphone should be turned on. However, your computer volume should be turned off all the way down, so that you do not hear anything that is any noise or anything that is going on the channel. You should not be able to hear. Okay, let's keep moving. Looks like there are no questions about this. During the exam, have a bunch of blank sheets of paper, so that you can write your exam on that, and have your writing supplies. I recommend that you answer one problem per one page, or in some instances, if you have to use 2 pages, use those 2 pages, just so that I think while uploading things to Gradescope, it becomes easier to map the pages to the problem numbers if you do it that way. That's a recommendation, not a requirement. During the exam, if you have any questions, type in private questions just to me. And on your answer sheets, please write your name and page number clearly, so that we know any scan, who does it belong to and which page number it is, so that we have a full stack and we don't lose pages in the middle. Okay, let's go on to the content. But before I start talking about the content, any questions about the logistics? So I guess, if you are familiar with logistics for exam 1 and 2, the only real change was the addition of the Laplace and Z transform tables that are on Piazza. Apart from that, everything is exactly the same way as it has been happening. Okay. So for the content, like what should you expect on the final exam? It is comprehensive, but if I just leave it at that, then it is a vast amount of information for you to be tested on. So in order for you to have specific targets and be able to use your time effectively, I have broken it down to specific topics, and in those topics, I'm listing out the core content that I'm going to try to test in the final exam. Now, a general rule of thumb here is generally the exams that you might see on the final exam are not going to have a lot of tricks to them. They are going to appear more straightforward questions, because I want to convey that these are the core ideas and this is what I want to test on. So in the previous two exams, there were a few tricks, and there were some. You had to be very careful while you were answering those problems. But in the final exam, you might notice that things are a bit more straightforward. So my guess at this time is that the averages are going to be higher compared to exam 1 and 2. Now, only time will tell, and only grading will tell if that is really the case. But that's what my estimate is right now. Now, I'm listing out some important topics that make up the class, and these will appear on the exam. Some of these may not be there depending on the length of the exam, but this is how you should utilize your time from now to Thursday. Signal operations and representation. How do you represent signals, a given signal, in terms of step functions, in terms of ramps, in bracket notation, in terms of impulses? Let me add on to this. So how do you represent those signals? Next, can you do these set of operations in the recommended order, or if you want to change the order of operations, then you'll have to keep track of the time shift. The time shift will become an advance instead of a delay if you change the order that was recommended. But doing time shift, scaling, and flipping operations, you should be familiar with that. How do you do it, and how do you sketch the after you perform a series of time shifts or scales and time flipping operations, can you sketch the resultant signal? This is first page, Clara. I'm going to reach to the second page in just a minute. So that's topic number 1. You should definitely expect a question on signal operations and representation, right? That's where we started, and without that, we wouldn't be able to do absolutely anything with the other problems. Convolution. So being able to perform convolution of two time domain signals is going to appear on the exam. There's no secret in that. Being able to convolve signals, either this is for continuous time only, so you should be able to do that. Next, for Fourier series, being able to determine the exponential Fourier series coefficients using the Fourier series tables. Now, we have essentially two known Fourier series coefficients. One is for the square wave, right, periodic square wave, and one is for the impulse train. We know the Fourier series coefficients for the standard square wave and standard impulse train. Being able to use this along with certain properties, right? For example, the two most important properties in my opinion are differentiation, time differentiation that is, and shifting, right? Time shifting. So can you use the Fourier series tables? and the standard results for Fourier series coefficients of square wave and impulse train, and be able to find the Fourier series coefficients of a given periodic waveform. So that's the next important topic. Followed by Fourier transform. So if I give you a general signal that may or may not be periodic, can you use the tables again to find the Fourier transform of that particular signal? So again, this will also involve using the properties of Fourier transform. So if you are not very fluent in finding the Fourier transform or Fourier series of a given signal, then I would recommend you to look at a few practice problems, look at the exams that were given. So for example, if I was preparing for the final exam and I know that Fourier series and Fourier transform is going to appear, suppose I took the exam in time slot 1. I would quickly go and check what were the questions for time slot 2 now and what was the solution. I could also use that as practice. So I would highly recommend you do that. Now, the next major topic was communication, and it was very closely related to sampling and reconstruction of signals. Now, from that, even though that's a very, very broad, multiple lectures we had on that, I'm going to aim at your skill to be able to track down a signal starting from the input, going through some multipliers and filters, applying the Nyquist rate concept for sampling. Are you sampling at Nyquist rate or not? Will you be able to reconstruct the signal from the set of samples or not? So that is going to be your next major topic. And the best way to prepare for this is to review the homework problems and take a look at some back exam problems. So wherever you see a block diagram and a bunch of multipliers and filters, try to go and take a look at that. Okay, let's see. The next topic I want to mention here is response of LTI systems. If there was one topic that could replace the title of the course, signals and systems, this would be it, response of LTI systems, right? That's a very very major topic here. So being able to apply superposition to find the response of LTI systems, being able to work in time versus frequency domain. We have seen that sometimes doing a convolution in time might be easier than multiplication in frequency domain, or in sometimes it is actually easier to work in the frequency domain and then take an inverse Fourier transform to find the response of that system. So being able to judge which domain you would want to work in, and obviously because we are talking about response of LTI systems, we can characterize the LTI system itself using its impulse response or step response. So being able to work with these is that is going to be tested on the final exam. Next, we come to Laplace transform, region of convergence, and finding out its inverse. This involves being able to use the Laplace tables, being able to perform partial fractions, being able to sketch the pole zero diagram, and from the location of the poles, being able to comment about stability, and being from the partial fractions and the ROC, being able to comment about whether the signal is right-sided, left-sided, whether it's a vertical strip or there's no region of convergence at all, right? So we looked at a lot of rules here. For example, we said for a right-sided signal, the region of convergence is going to be to the right of the rightmost pole, and so on. So being able to sketch those out in Laplace transform. Next, being able to sketch the root locus of a given feedback system. Being able to apply the Routh-Hurwitz criteria to comment about stability. Right. This was one of the last topics that we looked at in the course, and it is based off of a simple set of 10 or 12 rules, and you would apply that to sketch the root locus. And I recommend that you use some back exams to prepare for this, and go through the lecture notes again to review root locus. Being able to develop the route array because it is based off of a very standard procedure, it's not that difficult, but make sure that you get comfortable with developing that route array and then being able to comment about the stability. Um, Obviously, if the order of the polynomial is not too high, then you could also find the actual location of the poles and comment about the stability. So that the fact that I'm saying you will need to use the Routh-Hurwitz criteria suggests that you will have a higher order polynomial to work with. Next, this is the last topic here: Z transform, region of convergence, and finding out its inverse Z transform. So this, again, very similar to Laplace transform, involves how do you use the Z tables to find the Z transform or the inverse Z transform. Again, we will need to work with partial fraction expansion. The only difference between Z and Laplace is that we will save a Z term in the numerator because that will get our partial fractions in the standard form. Again, pole locations here and also the region of convergence over here. Difference is now you will be dealing with circles as opposed to the right of the plane and to the right of the pole and to the left of the pole. Now we'll be dealing with exterior of a pole and exterior of a circle and interior of a circle. So because Z transform was essentially our last topic, and we didn't have too much practice with that, we didn't have too much time to process this. The problem on Z transform is going to be pretty straightforward. So as long as you are able to look up the tables, do some partial fractions on that, you should be good. All right. So this is what I had planned. I hope that with this you do not panic. You do not become what am I trying to say? I want to say that use your time wisely, right? So design of Butterworth filters is probably not where I would spend my time. I would probably spend my time on these topics. Are they 9 total? Well, no, they are not 9 total problems. The number of problems are going to be less. What I want to point out is this is how you should prepare, right? So all these are not going to be on the exam. Some of these will be on the exam, but this is where you should focus on from now to the exam time. And in some cases, I might be able to combine some of these topics. So not 9 problems. I'm probably going to have close to maybe 8 or 7 problems. Again, I'll have to decide that once the exam is ready. I don't want you guys to feel that time is a factor, a major factor at least. So I'm a little bit sensitive to that, especially considering that it's a final exam. Is the exam going to be evenly cover the course material or more heavily cover the topic 6? So you see this, it's more even, right? So for example, if I highlight the topics that we had for exam 1, this was exam 1, that was exam 1, and I'm not sure if I think we had Fourier series for exam 2 actually. So exam 2, and then some of this was exam 2, some of this was not, and then we started having exam 3 here, right? So the answer to your question is more evenly spread out. Will it be the same format? No, I may have to just do free response questions. I might not have like a short answer, long answer breakout, the 2 sections. I might just go 7 or 8 free response questions, and that is it. Yeah, all long answer, but some of them will have parts. So it's difficult to say. here with the short answer and then long answer, what I've realized is if you spend a lot of time with the short answer questions, you might get a very good score, but that's just 30 points. And then you might that might eat away on your time that you will really need for the long answer. So just to have a more consistent format, I'm probably going to choose just long answer, but of course they will have parts, multiple sub questions. No problem. All right, so I'm gonna stop the recording here and then hang for a few minutes.